Okay, this video will explain and discuss about the encoder. So encoder is a digital circuit that convert information to a coded form. So example of the encoder, we have decimal to BCD. Okay, decimal we have 10 numbers, and then BCD we have 4 bits of binary. So 10:4. And then we have 8 line to 3 line encoder. So we have 8, from 8 we need to convert into 3. In encoder we have encoder, and we also have priority encoder. Okay, later on we'll discuss on the priority encoder. So the function of this encoder is to translate a decimal input to a BCD number. Okay, we look for the first example. We have decimal to BCD encoder. So the function of this encoder, we use this encoder in order to translate the decimal input into the BCD number, binary coded numbers. So it convert only one input at a time into a BCD code. So this is the logic symbol for the encoder. So under the encoder, it has the input and it also have the output. Okay, this one is decimal to BCD encoder. So the input are in decimal numbers, and then the output will be in the BCD. So it has 4 digit. 1 digit in decimal, 4 digit in BCD. So example here, let's say the question asks to design 10:4 encoder where only one input is active at one time. Okay. So example here, we need to construct the truth table for 10:4. That means we have 10 input and then we have 4 output. 10 here refer to decimal number. So the possibility of decimal number, we have 0 until 9. And then the output is BCD. So we have A, B, C, D. Because BCD number, we have 4 digit. 1 digit in decimal equal to 4 digit in binary. In BCD. So only one input is active at one times. Mean you can refer to this truth table. At one row, only one input is activate. Okay, 0, 1, the rest is 0. Okay, so we activate 0. So based on this truth table, at this point, okay, the user press 0. So 0 will be activated during this time, and then the output will be 0. Okay, when user press 1, so 1 will be activated, and then the output will be 0001. So it convert from decimal value to the BCD number at this point. Okay, so based on this truth table, okay, you should be able to identify the Boolean expression. How to identify the Boolean expression is based on the output column and refer to output equal to 1. Okay, based on the SOP. So at this point we have 4 output, 4 column of output. We have A, B, C, and D. So that means we have 4 Boolean expression. Okay, look at the first one. We have A. So A output 1 equal at this part. Okay, when we press number 8 and when we press number 9. So A here equal to 8 plus 9. Okay, next for B, okay, the output equal to 1 at this value, number 4, number 5, number 6, and number 7. So we add both 5 plus 4 plus 5 plus 6 and plus 7. Okay, for C, okay, 1 at the output number 2 plus number 3, and then plus at number 6 and number 7. And for D, okay, output 1 at the number 1, so number 1 plus number 3 plus number 5 plus number 7 plus number 9. So at the end, this is the Boolean expression for encoder decimal to BCD. So based on the Boolean expression, Now you can draw the logic circuit for the decimal to BCD encoder. So the output will be for A, B, C, and D. And then the input is begin from 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, based on this Boolean expression. Okay, the next encoder is referred to priority encoder. So the first one is the simple encoder. This one is the priority encoder. So this priority encoder, also known as 10:4 priority encoder, it will produce a BCD output corresponding to the highest order decimal digit input that is active and will ignore any other lower order active input. So that means it only corresponding or only consider on the higher decimal input. So let's say you press 2 number, it will activate the highest number. Okay, for example, when both 3 and 6 input are activated, so BCD output is 0, 1, 1, 0, which is referred to number 6. Okay, it will ignore the lower order, it will corresponding on the highest order decimal. So let's say you press on the number 3 and number 6, so it will take 6 as the input value. So in priority encoder, the logic symbol is like this one. Okay, we have 1 until 9, and then we have the output based on the BCD. So we have 4 output A, B, C, D also. Okay, so this is the truth table for the decimal to BCD priority encoder. Okay, the input we have from 0 until 9 because this is decimal numbers. And then we have the output A, B, C, and D. Okay, the difference between the simple encoder and the priority encoder is under the priority encoder we have the don't care term. X is referred to the don't care term. So under priority encoder we have the don't care term. Okay, so 0 will be don't care. Everything is don't care. So the output will be 0. Okay, for number 1, so let's say number 1 is press. Okay, so the output will be 0, 0, 1. And it follows until number 9. So these are the output, the input, and these are the output. Okay, don't cater means it can be 1 or it can be 0. Okay, it can be 1 and it can be 0. Okay, for example here, let's say you press number 0 and number 1 simultaneously. Okay, so don't care when you press, it can be 1 because you press the number, and it also can be 0. You don't press that number, but it only take the highest order. Okay, let's say we have 0 and 1, so the highest order is 1. So the value of the value that the encoder take is 1, because 1 is more higher compared to number 0. Okay, let's say here we have number 6 and number 5. If you press both number, it will only take the value of number 6. Okay, priority encoder only correspond on the higher order number in decimal. Okay, that's why the rest are don't care term. So based on this truth table, you need to extract the Boolean expression. Boolean expression. How to identify the Boolean expression is based on the output value. So here we have A, 8 times 9 node plus 9. And then we have B, Boolean expression, C and D, Boolean expression. So based on this Boolean expression, you need to do simplification. Okay, A here, number 1 at this point, we have 8, and then 8, here we have 0, so 8 times 9 node plus with 9. Okay, how we get 8 times 9 note plus 9 is refer to this table. Okay, A1 is come from 8 times 9 note plus with 9. Okay, so the rest also similar. So the next part, after you get the Boolean expression, you need to simplify the Boolean expression. How to simplify? Okay, let's say here we have 8 9 note plus 9. So 9 note plus 9 here, you can discuss 9 note. If there are similar number, let's say we have 9 note and then we have 9, so you can discuss 9 note. So the expression now is 8 plus 9. Okay, same goes to the others for B, C and D. Okay, let's say here we have 4. There is no 4 note, so we need to maintain 4. Okay, next we have 5. So we can discard the 5 note. All the 5 note we can discard. 6, we have 6, so we can discard number 6. Number 7, we have number 7 here, so we can discard number 7 here. So at the end, it will be B equal to 4 times 8 notes times 9 note plus 5 times 8 note times 9 note plus 6 times 8 note times 9 note plus 7 times 8 note times 9 note. Okay, the rest also similar. Okay, so the next video we will discuss on the decoder.